Starship flies for a 6th time on one of its most aggressive flights so far. We've got lunar news coming from SpaceX, NASA, and even China, and Blue Origin's New Glenn is getting ready to fire. We'll have all that and a whole lot more this week in Spaceflight. This week, SpaceX's Starship rocket flew for a 6th time, and as usual, there's a lot to unpack, so let's start from the beginning. Liftoff took place on November 19th at 2200 UTC from Orbital Launch Pad A at Starbase, Texas. The vehicles flying for this mission were Booster 13 and Ship 31. Now, in general terms, this mission was planned to be very similar to the previous flight. Launch, head over the Gulf of Mexico, separate the stages, return the booster for a catch, re-enter with the ship, and perform a soft splashdown in the Indian Ocean. However, there were very small differences for this flight that we already outlined 2 episodes ago of This Week in Spaceflight, so watch that for a much more detailed rundown. Now, of course, the important thing is not what was planned, but what actually happened. Booster 13 lit all 33 of its engines, and Starship lifted off from Starbase, heading over the Gulf of Mexico in the bright afternoon light with clear blue skies. The flight was scheduled to occur at 4 p.m. local time, which would mean that later in the flight, the ship would re-enter in daylight, but we'll get to that in a bit. Now, once again, the hot staging maneuver went well, and Booster 13 started its flip and boost back burn to return back closer to shore. This was hoped to be for a catch, but unfortunately, unlike on Flight 5, this catch was aborted. There were some confusing callouts during the stream that initially indicated that the tower was go for that catch, but then we heard booster offshore divert on the nets. SpaceX later clarified after the flight on its website that, quote, automated health checks of critical hardware on the launch and catch tower triggered an abort of the catch attempt. Elon further confirmed on X that this was because they had lost communications to the tower computers and that, while the catch could have still worked, teams decided to err on the side of caution. For this mission, it's probably fair to say that it was the ship's flight that was much more important. Since it was the last Block 1 ship, SpaceX had a much more aggressive test profile planned for it. After a successful ascent, Ship 31 was set to perform a relight of one of its sea-level Raptor engines in microgravity using its header tanks. This relight, performed about 37 minutes into flight, worked like a charm, and it demonstrated that Starship would be able to control its deorbit in future orbital flights. It's worth a reminder that while this was a test for deorbit capability, the ship was not in an orbital trajectory, and in fact, it wasn't even a retrograde burn, but rather a prograde burn, adding a bit under 100 kilometers per hour to Ship 31's speed. The ship's entry was another big-ticket item. It worked on Flight 4, and worked even better on Flight 5, and for Flight 6, SpaceX didn't even bother overhauling the heat shield like they did with Ship 30, so big portions of the heat shield were still old style. SpaceX only changed the heat shield on the locations most prone to damage during re-entry with newer tiles and backup ablative material. Another big objective was to see whether the ship could survive re-entry with several columns of tiles missing from the sides of the vehicle. SpaceX confirmed during its stream that the teams had removed over 2,100 tiles during this work, and that this would give them an idea on where best to put hardware that will enable ship catches in the future. Once more, the heat shield looked as though it was damaged during re-entry, with at least one visible burn-through on the forward starboard flap, but less severe than those seen on Flights 4 and 5. More important was the state of the side of bare steel that was visible on the live re-entry footage. This side progressively became more and more wrinkled, and by the end of re-entry, it looked like there might have even been a breach on the hull. Despite this damage, the ship made it through the plasma phase of re-entry and initiated its belly flop maneuver as usual. On this mission, however, all of this happened in daylight, which gave us an amazing view of the ship as it was descending through the clouds. Also on this mission was another important test, as the ship was programmed to fly at a higher angle of attack. During its coverage, SpaceX explained that this would mean the ship would fly more nose down than usual, and that this was to have more control on the cross range of the ship, as they want to bring it back to the launch tower for a catch in the near future. This higher angle of attack stresses the aerodynamic control of the flaps, and therefore it was a key test to gather more data on Starship's control capabilities. Ship 31 then successfully relit 3 of its engines, flipped, down-selected to 2 engines, and landed softly in the Indian Ocean about 1 hour and 5.5 minutes after liftoff. This time, thanks to the daytime landing, we were able to not only see the flip from the flap camera, but also from the assets that SpaceX had deployed in the area, both from the air and the sea. From the footage, we were able to see what appeared to be missing tiles on the belly of the ship, so that'll be something SpaceX will have to look at carefully and fix for the future. This is, in fact, one of the things that Elon later outlined after flight, saying, quote, "The biggest technology challenge remaining for Starship is a fully and immediately reusable heat shield." He also confirmed that adding metallic shielding on the ship, supplemented by ullage gas or liquid film cooling, is back on the table as a possibility. These were options that SpaceX had contemplated in the past as alternatives to the tiles. In fact, SpaceX had said during its coverage that Ship 31 carried new test materials for its heat shield, including steel tiles on some locations. In the end, the result of all this heat shield experimenting may be that there's not just one single solution needed to protect the ship against re-entry, but rather, there'll need to be multiple systems. This is evidenced by the fact that while the tank and the payload bay sections are all basically a cylinder, so all is equal, there are parts which aren't equal, like the flaps and the aero covers, and these may need more specific ways of being protected during re-entry that aren't tiles. Also, given the damage incurred on the sides of the ship, maybe these places will see other styles of heat shield applied to them to protect against re-entry while not being fragile against a catch, like the ceramic tiles might be. This was the end of an era, as it was the last launch of Block 1 of the ship, and starting on Flight 7, SpaceX will fly Block 2 of the ship with several upgrades that we'll cover in detail in a future video. Elon mentioned that this next flight will feature another ocean splashdown, and if that works out, SpaceX will then try catching a ship on the subsequent flight, which would be Flight 8. A ship catch attempt on Flight 8 would mean that Starship will have to go into orbit in order to return all the way back to Starbase. It'll be interesting to see what the full plan for Flight 7, the mission leading up to that one, will look like, and we'll be covering all of that here at NSF and on This Week in Spaceflight. So don't forget to give a like and subscribe so you don't miss all of the latest news and stories. During SpaceX's coverage of Starship's sixth flight, the company also revealed further information about missions further down the line, including the work being done for Starship Mars missions, as well as new views of the Starship Human Landing System for NASA's Artemis program. SpaceX said that it's been actively working on new heat shield materials for Starship that would allow it to survive a re-entry on Mars. The company tested these materials in a plasma jet chamber at the University of Illinois Urbana-Champaign, where they were exposed not only to the high temperatures of re-entry, but also to the high concentrations of carbon dioxide of Mars's atmosphere. This creates a more challenging environment with more atomic oxygen present in the plasma flow than during a re-entry on Earth, something that can chemically react with materials and make surviving re-entry much harder. But Mars isn't the only celestial body on SpaceX's crosshairs. The company's developing the Starship Human Landing System to support NASA's Artemis program, the lander that will return humans to the lunar surface for the first time since 1972. The new renders released this week show a notable difference compared to the last ones that we saw a few years ago. One of the more striking differences is the removal of the fixed solar panels on the body of Starship, which are now replaced by deployable solar panels stored on the payload bay under the crew quarters. The ship also sports several navigation lights, modified windows, and what appears to be black thermal material for the legs, engine section, and the areas around the landing engines. The renders also show that the deorbit burn will be initiated with 2 of the sea-level Raptors on the ship, a departure from a previous render indicating a sea-level and Raptor vacuum engine would be used instead. And most importantly, we finally got our first glimpse at what an on-orbit refueling of a tanker would look like with a Starship depot ship. In the render, the depot looks pretty much like a stripped-down version of HLS with no crew cabin or landing engines, but it would still feature the deployable solar panels as evidenced by the same rectangular openings. The render also gives an idea of how SpaceX plans to connect a tanker and a depot in orbit for propellant refilling, but it could also just be artistic license. All of this comes right on the heels of NASA announcing that it plans for SpaceX's Starship lander to carry, in cargo configuration, JAXA's pressurized rover to the surface of the moon no earlier than fiscal year 2032 in support of Artemis 7. This would then be followed by a Blue Origin Blue Moon lander, also in cargo configuration, carrying a lunar surface habitat no earlier than fiscal year 2033. These missions and this hardware would kickstart surface base operations for the Artemis program, something that SpaceX says it's ready to support as well. One of the renders the company released envisions a pair of advanced Starship Human Landing System ships with way more windows for many more crew members and a lunar base in between the vehicles. Here's hoping we get to see all of that and a whole lot more in the near future. Before these missions can actually land on the moon, NASA first needs to fly Orion with astronauts on board. It currently plans to do that with Artemis II, which will send humans on a trajectory around the moon for the first time since the early 1970s. But before NASA can launch this mission, it first has to put all the pieces of the rocket together. This week, NASA started that process in the Vehicle Assembly Building at the Kennedy Space Center by installing the first segment of the left solid rocket booster on Mobile Launcher 1. The next step is repeating the same procedure for the right booster. Artemis II is currently scheduled for September of 2025, but that date is anything but certain, as NASA is still working to solve a few issues with the heat shield on the Orion capsule. When Orion re-entered during the previous mission, its heat shield suffered much more damage than NASA expected. Recently, NASA officials announced that the agency had found the root cause for this issue, but they hadn't yet decided how to mitigate it on Artemis II. After all, both the capsule and the heat shield for that mission have already been completed, so it'll be a lot harder to change them now. The decision on what to do hasn't been made yet, and it's expected by the end of this year. But if NASA has now started stacking SLS, doesn't that mean that it'll have to launch within a year? Well, not necessarily. If you followed along with Artemis 1, you might remember that the clock starts ticking once NASA starts stacking the boosters. This is because the seals between the booster segments are only certified for a year. Now, as we saw with Artemis 1, NASA can extend that certification, but it would rather avoid it if possible. Well, that clock hasn't started ticking just yet, but it will as soon as they start stacking the next layer of booster segments. NASA has previously said that it doesn't want to wait with this step, but it might have to if the decision on the heat shield isn't made soon. So should we get excited about a human mission around the moon next year? Well, we'll have to keep our eyes peeled and follow what NASA is doing in the VAB. If they start the clock on these booster segments, we might see the mission as soon as September. But if NASA takes its time, we'll have to keep our excitement contained for just a little bit longer. And now we'll take a glimpse at some other stories across space, starting with China's plans to send humans to the moon. Yeah, we're not done talking about the moon just yet, but come on, we can't really complain about that, right? This week, China's Human Spaceflight Agency released a new video showing the profile of an upcoming lunar mission. The two spacecraft for this mission, the Mengzhou crew capsule and the Lanya lunar lander, will launch separately and then dock while on their way to the moon. After separating into lunar orbit, Lanya will descend and land on the surface. Once there, the astronauts will explore the surroundings and collect samples by traveling around with a rover. NASA did something similar with the lunar roving vehicle during the Apollo program, which allowed the Apollo 17 astronauts to drive over 35 kilometers on the lunar surface. In the video, we can also see how China is preparing for this mission. Prototype hardware is on its way for Lanya, the lunar spacesuit, the rover, and Mengzhou, which has already performed a parachute test. China hopes to perform this mission before 2030, so now both China and the US are working to get to the moon in this decade. The new space race has clearly arrived. The European Space Agency has awarded contract extensions to 4 European rocket startups: Isar Aerospace, Rocket Factory Augsburg, Orbex, and HyImpulse. The 4 companies have all received funds from ESA under the Boost program in the last few years, and now they're all gearing up for their first orbital flight attempts. Since none of these companies have an operational rocket yet, the rockets don't generate any revenue for the companies, and unfortunately, the final steps toward the first flight are expensive. ESA wants to make sure the companies can all get through this phase, so it awarded a total of 44.22 million euros in funding spread over the 4 companies. Hopefully, this will help Europe build out its much-needed launch capabilities. Another European space company also raised funds this week. The Exploration Company is working on a cargo capsule called Nix, and the company raised $160 million to pay for its development. This brings the total funding for Nix up to $230 million. Nix will be a reusable cargo spacecraft for delivering supplies to space stations, and it's capable of taking 3,000 kilograms of cargo back to Earth. The capsule's designed to be launched with any heavy launcher in the world, so the Exploration Company hopes that'll make Nix 25 to 50% cheaper than competing vehicles. Nix's first flight to the International Space Station is currently scheduled for 2028, but before then, it's planning to fly a smaller test capsule called Mission Possible next year. You might also remember that the company flew an even smaller capsule called Bikini on Ariane 6's inaugural flight earlier this year. With all of these tests, the Exploration Company is working hard to make Nix a reality. Another space startup has unfortunately abandoned its mission. This week, ABL Space Systems founder Dan Piemont announced that the company is stepping away from the commercial launch market to focus on missile defense. ABL had been working on its rocket, RS-1, that was capable of launching up to 1,350 kilograms of payload into low Earth orbit. This payload could launch from many places, as the ground infrastructure supporting this vehicle is built to be packed into shipping containers and deployed wherever needed. Unfortunately, RS-1's first flight ended in failure shortly after liftoff, and the second vehicle didn't even make it that far. It was lost after an anomaly during a static fire in July. Following this failure, the company had to downsize significantly to stay afloat, and with this change of direction has unfortunately come even more layoffs. According to Piedmont's statement, the reason for the refocus is that ABL is no longer able to make a meaningful impact on the launch industry. But is that the only reason? The small launch market isn't booming as much as was predicted years ago, and many other companies have also left the space as a result. But this change doesn't spell the end of RS-1, as ABL now hopes to repurpose it for defense purposes. It is, however, unclear what will happen with the commercial contracts that the company has already secured. Gravitics has shared new information about its range of space station modules. The company wants to build space station modules for other businesses that are working on space stations. Previously, it offered a station module called StarMax, and at 7.6 meters in diameter and 9.8 meters tall, it's not a small one. In fact, the pressurized volume of StarMax is nearly half that of the ISS, but this week, Gravitics removed the StarMax page from its website and replaced it with a page called Real Estate. The new website showcases a whole range of space station modules and other orbital vehicles, including living quarters, an arena with giant windows, a manufacturing module, an orbital data center, a fuel depot, a resupply vehicle, and a garage? Yes, a garage! But not for parking your car, or spaceship, I guess. This garage is designed to keep and deploy satellites. Earlier this year, Gravitics won a contract from the US Space Force to develop orbital platforms for responsive space missions. While it's not clear what these platforms might look like, the newly revealed garage might just fit the bill. It'll be interesting to see what customers Gravitics may find for these concepts. Some of them are really cool and would make some great additions to a space station. This week, Impulse Space unveiled its new engine called Deneb. The company was founded in 2021 by Tom Mueller, who previously worked for SpaceX and designed the Merlin engine that powers the Falcon family. Now he's been working on another engine for his own company. The new engine is powered by methane and runs on the oxidizer-rich staged combustion cycle. According to Mueller, this will be the highest performing hydrocarbon-fueled rocket engine to fly. It's named after the brightest star in the Cygnus constellation, Deneb, which is a blue supergiant star. Quite a fitting name, considering the blue flame that we know and love to see from other methane-powered engines. Mueller designed Deneb to power Impulse's upcoming space tug, Helios, which is designed to ferry spacecraft from low Earth orbit to geostationary orbit in less than a day, much quicker than it usually takes. With the first development engine for Helios now completed and ready to test, Impulse is working to fly Helios for the first time in 2026. Blue Origin is getting ready to hotfire New Glenn's first stage for the very first time. This week, Blue opened the hangar doors to roll the fully integrated New Glenn stack out to the launch pad. Once there, it's expected to light up its 7 BE-4 engines for a hotfire or static fire test very soon. This is just one of the many things that Blue Origin's been doing to prepare for New Glenn's upcoming maiden flight. The company has also been practicing recovery operations. This week, NSF's own Julia Begeron spotted Blue's landing platform, Jacqueline, returning to Port Canaveral after sea trials. On board was a New Glenn mock-up with an umbilical panel. Right beside it, you can see a remotely controlled robot with inspection cameras on a robotic arm, which Blue will likely use to check out the rocket after landing. With all of this work going on, Blue Origin is getting ready to launch New Glenn soon. We don't have a date yet, but we're definitely getting closer and closer to an exciting flight. Now let's take a look at the space traffic this week and see what's coming up next week in spaceflight. This was quite an active week with 5 launches from SpaceX, 4 of them with Falcon 9, and the other one, of course, being Starship. The first of these launches came at the beginning of the week, with a Falcon 9 lifting off on November 17th at 22:28 UTC from Historic Launch Complex 39A, carrying a somewhat secretive payload into a geosynchronous transfer orbit. This payload goes by at least 2 known names. On official documentation like NOTAM's or the FAA's website, the mission is known as Optus-X, while SpaceX officially called the mission and payload TD-7. It's unknown what this payload or payloads are for, or who ordered them, as SpaceX didn't reveal their customer, and said customer also requested SpaceX to not show views of the payload or even the second stage sending the payload into geosynchronous transfer orbit. The name Optus X would lead one to think that perhaps the Australian communications company Optus might be related to this mission. NSF approached the company for comments on the mission, and despite promising to contact us back with more information, they never followed up on it. So, for now, the identity and purpose of the payload remains a mystery. Of course, this being a Falcon 9 mission, it featured a flight-proven booster, B-1077, flying for a 16th time. It successfully returned back to Earth, landing on SpaceX's drone ship, a shortfall of Gravitas. Right on the heels of that launch, another Falcon 9 rocket took flight, but this time from Vandenberg. Liftoff took place on November 18th at 5:53 UTC from Space Launch Complex 4 East, carrying another batch of Starlink Direct-to-Cell and Starlink V2 mini satellites. The first stage, B-1071, was flying for a 20th time, becoming the 6th Falcon 9 booster to fly 20 times. It successfully returned to Earth, landing on SpaceX's drone ship, Of Course I Still Love You. This mission marked the fastest turnaround time from SpaceX's West Coast launch pad, going from 4 days and 12 hours on the previous record to just 4 days and 30.5 minutes. Going back to Florida, there was another Falcon 9 launch, this time from Pad 40. Liftoff took place on November 18th at 18:31 UTC, completing SpaceX's third Falcon 9 launch in the span of about 20 hours. The rocket was carrying the GSAT-20 satellite into geosynchronous transfer orbit for the Indian Space Research Organization, or ISRO for short. GSAT-20 is India's latest high-throughput communications satellite and was designed and built by the commercial branch of ISRO called New Space India Limited, or NSIL for short. The satellite was originally planned to launch on India's Launch Vehicle Mark III, but during its design and development process, the satellite's mass grew beyond the capabilities of this rocket to get it to a geosynchronous transfer orbit, so ISRO looked at foreign rockets to launch the satellite. The agency had initially considered ArianeGroup's Ariane 6 rocket, but with delays in its development, ISRO eventually selected SpaceX's Falcon 9 to launch the satellite. GSAT-20 was successfully dropped into its target orbit, and teams on the ground have already started its post-launch on-orbit checkouts and orbit raising. The first stage for this Falcon 9 launch was B-1073, which was flying for the 19th time. The booster successfully landed on SpaceX's drone ship Just Read the Instructions, ready for another use at a later date. For the next launch, we'll go all the way to Kazakhstan, where Roscosmos launched the latest Progress cargo resupply vehicle to the International Space Station. Liftoff of the Progress MS-29 spacecraft took place on November 21st at 12:22 UTC from Site 31-6 at the Baikonur Cosmodrome. After an 8.5-minute ride into orbit, the Progress MS-29 spacecraft successfully separated from the third stage of its Soyuz 2.1A rocket and started its 2-day trip to the orbiting laboratory. The vehicle, filled with about 3 tons of supplies, experiments, and fuel, is set to dock to the Poisk module on November 23rd at 14:35 UTC. The fourth and final Falcon 9 launch of the week took place just yesterday, once again from Pad 40. The launch happened on November 21st at 15:07 UTC and carried another batch of Starlink V2 mini satellites into low Earth orbit. The first stage for this mission, B-1069, was flying for a 20th time, becoming the 7th booster in the fleet to reach 20 flights. As customary, it successfully landed on SpaceX's drone ship, a shortfall of Gravitas. With the 2 Starlink launches this week, SpaceX has now launched a total of 7,368 satellites, of which 668 have re-entered and 5,953 have moved into their operational orbit. As of recording, there were a few other launches scheduled to take place. So here's Ryan Caton for a last-minute update on this week's space traffic.
Thanks, Elysia. Unfortunately, that few turned into just one launch, as the Electron/HASTE Leidos Mission 2 launch was scrubbed just 3 minutes before launch last night. However, we did get another suborbital flight with NS-28 on board New Shepard from Blue Origin. Liftoff took place from West Texas at 15:31 UTC today, Friday, November 22nd, on board NS-4. That's the tail number of the booster supporting this flight. Inside of the capsule for New Shepard's 9th crewed flight was a 6-person crew consisting of Emily Candrali, Sharon Hagel, Mark Hagel, Austin Littoral, James Russell, and Henry Wolfond. Interesting to note that Hagels were actually flying on New Shepard for the 2nd time. Everything went off without a hitch, and the booster successfully returned back to the ground, performing its classic vertical landing. The same can be said for the capsule, which successfully descended gracefully to the desert under its 3 main parachutes before cushioning its landing.
Going into next week, we'll once again have a lot more launches, so get ready. The first should come from the US West Coast, with the Falcon 9 launching another Starlink batch. The 4-hour window for this mission is set to open on November 24th at 3:26 UTC. Just minutes after that, we should have the next launch of Rocket Lab's Electron rocket from New Zealand with the mission ACE Baby. ACE, AIS, stands for Automatic Identification System, as this mission is aimed at maximizing the detection of ships with ACE transponders. The instantaneous launch window for this mission is currently set for November 24th at 3:55 UTC. Going back to the United States, 2 more Falcon 9 launches are set to occur back-to-back from Florida. The first one, from Pad 40, has a 4-hour launch window set to open on November 25th at 9:32 UTC. The second Falcon 9, this one from Pad 39A, also has a 4-hour launch window, opening on November 26th at 3:31 UTC. And to wrap up the week, we'll have a military launch of a Soyuz rocket from Plesetsk. Notice-to-air missions and marine hazard notices indicate that this could take place anytime within a 2-hour window that opens on November 27th at 1900 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and I'll see you all again next week to recap this week in spaceflight.